Okay, two where you're going to be plotting r comma theta, and the graph paper is already provided on the test, so I'm just going to give you, I'm not going to go get you graph paper to use just for these examples. I'll just do some that aren't so bad. So I have 2 points I want to plot. I want to plot the point 245 degrees. So where's 45 degrees located?
In between the 90 and 0.
So it'd be right here, right?
Yeah.
And we'd go out how many radiuses?
2.
2. So 1, 2. So there would be point A. Okay, what about point B? 300 degrees. So 300 degrees would be in the fourth quadrant, right?
Yeah.
And it's easier to see on my graph that I have on your paper because I did increments of 15, so it's easier for you to find them. So -3, and what do you do when it's negative? Go the opposite direction. So it'd be somewhere there. Do you guys want more examples of plotting points?
No.
Okay, moving on. 2, where you're changing rectangular coordinates to polar coordinates. And the formula is r equals the square root of x squared plus y squared. And theta equals the arc tangent of y divided by x. But if x is negative, you add 180 degrees. Which is the same formula as you use for the a plus bi, right? It's just written in different format. Now, what I saw most of you had trouble with is one like this. So here's an example. Oh, let's make it, let me put a number in front of this one. Okay, so this is x and this is y, and we want to change it to polar form. So r equals the square root of, what's my x?
-2.
And I'm going to square it. What's my y?
2 square root of 3 squared. So it would be 4.
This one will be 4. And when you square this, remember you got to square both. That was the common mistake I saw in homework. So 2 squared is 4, and the radical 3 squared is
3.
So this ends up being 12 plus 4 is,
16.
so r is
4.
4. Now arctangent of y, 2 square roots of 3 over a -2. I did this one on purpose. I put a negative down there because that's the other mistake I see commonly, is you forget to put or add 180. So this ends up being a negative square root of 3. Well, it's the arctangent of a negative square root of 3.
It is negative 60 degrees.
And then don't we have to add 180 because
So it's 120.
120. So the answer for this one is 120 degrees. Okay, here's another one if you need it. You don't have to write it down if you don't want to. Another common mistake was this kind. I have 0 and -5 for my x and y. So r is going to equal 0 squared plus, so it ends up being 5. What's theta? The arctangent. It's undefined. That means calculator's not going to do the work for you. You got to use your brain.
If it's negative, it'll be at
270. If it's positive, it's 90. So this one is 270. So our answer for this one is 270. Does anybody need more examples of changing rectangular to polar?
So if you're, like, our tangent ends up being undefined.
Then you gotta make the decision. If it's a positive 5 on top, for instance, it would have been a 90. But since it's negative, you go 270. Okay, good?
E.
Next. What's next?
Or theta.
R theta to xy. So you're changing two R thetas to x comma y. Formula is x equals r cosine of theta, y equals r sine of theta. And this group you may fear mistakes on. But the key thing on this one is you want this to be in degrees. You can use rads if you, but be very careful with your calculators. What do you gotta worry about when you use your calculator to change the rads? You gotta remember to switch it back to degrees, okay? So let's do one that's one of each basically. Let's go 5, 7 pi over 4. I want to change it to its rectangular coordinate, x comma y. Now, I didn't mention, but you guys shouldn't miss these, right?
Right, you can check.
Because you can visually check them. Where is 0, -5 on the polar plane? Wouldn't it be to the origin and down 5? Okay. Where is 5, 270 on the polar plane? 270 is down here and down 5. Doesn't it land at the same place? So you don't even have to graph them, but you could think visually where they look, and you should be able to check. So you really shouldn't miss any of these. Okay, so this one, do you want to change it to degrees?
Yeah.
So times 180 over pi. So 7 times that's what? 315? So we've got 5, 315. So x is going to equal 5 times the cosine of 315. And y is going to equal 5 times the sine of 315. Now that's one of our common angles, right? That's 45 degrees. So I know cosine of 45 degrees is square root of 2 over 2. So it'd be 5 square root of 2 over 2. Sine of 315 is the same thing, but it's negative.
What was it? Was it 5 square root of 2 over 2?
Yeah, 5 square root of 2 over 2. And that's going to be negative 5 square root of 2 over 2.
And we don't do decimals.
You can, but if it's exact, let's do exact when you can.
More likely to have decimals with rads.
So we
Yes.
don't really have that.
That's what I got this. I did that instead because it makes so
Trig sheet.
much fun.
Yeah.
Okay, does everybody follow that one? Because we know that's 45 degrees, which is square root of 2, and it's in the fourth quadrant. And then we just put it in. Now, you could also have something like one that ends up being a decimal. Let's do one of those. Let's go 2, and let's say I've got 78 degrees. So I know x is going to equal 2 times the cosine of 78. On this one, you're going to round your answers to nearest hundredths. Y is going to be 2 times the sine of 78 because this is not a common angle. So does anybody have their calculator? Can tell me what you get?
0.42.
0.42 for the first one?
Yep. 1.96.
Anybody else agree? Are we okay with changing polar to rectangular? Next, what are we ready for? Operations of complex numbers. I think you should be able, there's 3 of these. You should be able to FOIL.
Oh, yeah, go to the decimal.
You should be able to divide. And you should be able to simplify. Ooh.
So we're gonna do one of each.
One of each. should be able to use FOIL, should be able to do division, and should be able to simplify, which on this, don't you need to remember that I to the 0 is
1.
I to the first, I to the second, -1, and I cubed, -I? Okay, we'll start with Delaney. FOILing, what would be first times first?
First one's first is 6.
Outer,
7 negative 8i
inner,
plus 15i
last times last.
minus 20i squared.
Okay.
I squared.
And then back, what does the I squared change to?
-1,
So that makes that a,
positive 20.
so then what's 6 plus 20?
26.
And then what's a negative 8i plus 15i?
7.
And that would be our answer. Okay, no. Division, what do we do when we divide?
Do the conjugate?
What's the conjugate?
It's 3 plus 6i.
Correct. You get to do the bottom, which to multiply conjugates, remember it's just first times first and last times last.
Well, what'd you say?
First times first
Okay, that would be 9.
and last times last, because the inner and outer are always going to cancel.
So then it would be negative 6
I,
squared.
okay. Mason, you get to do the FOIL on the top part.
What was that? No, negative 36 I squared. Okay, it'll be 15 plus 30i plus 6i plus 12i squared.
And Delaney, yes, you get to do the simplification. What's I squared going to change to?
-1, so it's negative 12.
So what's 15 minus 12?
30,
And what's 30 plus 6?
36.
Look, that didn't look good. And then on the bottom, the I squared's going to change to,
-1, so it's positive 36.
so what's 9 plus 36?
45.
Now, can I do anything else to that one? Okay.
Divide by 3, no?
Yeah, you can reduce. So 3 divided by 3 would be
1,
36 divided by 3, 12.
12,
And 45 divided by 3,
15.
15.
You can also, you can never know.
Okay, next one. Okay, we remember I to the 0, I to the first, I to the second, I to the third. So if I were to distribute this, Tara, what would you get?
Here, give me this one here. You're distributing, okay? So you would get 6i to the 6th power.
Remember when you multiply, you add
I was
exponents?
just kidding, to the 5th power.
There we go.
And then you would get 10 to the 6th power, blah, blah, blah.
Okay, now, can you have an I that has a power greater than 1 in your answer?
No.
No, so that means you've got to simplify. How did we simplify when we had I's with
We
powers?
divided by 4.
Divided by 4, because they cycled every fourth one, right? So what's 5 divided by 4? Remainder of,
1.
so that's 6 to the I to the first, right? Which is I. What's 6 divided by 4? Remainder of, so this one would be I squared, and what's I squared changed to?
-1.
So it ends up being what there? -1 times -10 would be plus 10? Everybody good there? So again, we just distributed, then we had I to the 5th we needed to change, or you could have looked at this. If you have I to the 3rd, don't you know I to the 4th is next? And it repeats itself. I to the 5th is the next one in line. I to the 6th is, and we could have done the conversion right there. We know that would have changed to just plain I. And we know the I to the 6th would change to -1, so we get a positive 10. So since they weren't very large powers, you could just cycle on. Okay, questions on the complex number, operations with complex numbers? Do I want more?
No.
Okay, next then. A plus BI form, so complex form. You got two of these. To R cis theta, and what's that cis theta stand for? Cosine theta plus I sine of theta. And I could write it either way on the test and you know what it means, correct? Okay, so we want to change, and now what's the equations or formulas we use to change?
R equals square root of x squared plus y squared.
In this case, a squared plus b squared, but it's the same scenario, right? Theta,
And the arctangent of b over a, if a is negative, then you add
and that's what I will tell you somebody will forget to. If a is negative, you gotta add 180 every time. Okay, so let's see, we've got, let's go 5 plus 4i. We want to change it. So Wyatt, you get to help me find the r.
5 square root of 5 squared plus 4 squared. 16.
So 41? Okay.
Prime.
Theta. Arctangent of Taylor, what's it gonna be?
over 5.
Do I need to add 180 on this one?
No.
Okay,
So
so,
we're in DMS,
yeah, degrees minutes second.
so 38 degrees and 40 minutes.
So our answer on this one is 41 cis, 38 degrees 40. And if you prefer, you can write square root of 41 cosine of 3840 plus I sine of 3840. They both mean the same thing. Okay, let's do one that has maybe a problem child in it. -2. So a -2 is -2 plus 0i. So we need to find r, so we're ready for JC. What's r gonna be?
Square root, so negative 2 squared plus 0 squared. Yeah, 2.
2. Because that's 4, right? That's root 4. Okay, so what's theta gonna be, Richard?
It's gonna be the arctangent of 0 over -2. Make sure that the negatives.
We need to add 180. And what's, is 0 divided by 2, 0?
So you just.
And that's 0. So plus 180 ends up being 180, is that right? So that's 2 cis 180. Okay, we're good there? Next is going the other direction. So if we're changing r cis theta to complex form, what do you have to do? And there's two of these. What do you do to change it?
You distribute.
That's it. That's all you gotta do is distribute. Be careful. What do you gotta be careful about?
What's this stand for?
Whether it's in degrees or whether it's in
Radians.
radians. So let's do one that's obvious. Let's do 2 cosine of 5 plus I sine of 5. So I would want to change my calculator to rads, or somebody else might want to change it to degrees by multiplying by 180 over pi, or pi over 180, whichever you guys prefer. Which would you rather, rads?
No, you can change
0.57.
Yeah. Only yours, yeah.
You multiply by 180 over pi if you want to change to degrees.
I got.
Okay, but did you guys change the rads to your calculators?
Yeah, I got
Yeah.
0.57.
Yeah.
Okay, so the first one is what, 0.57?
Yeah.
Yep.
And then negative 1.92.
Negative 1.92i.
Yep.
That's what I got too.
Does everybody concur? Agree there? Now, let's do one that's, now notice I wrote that one as cosine plus I sine, so it could be written either way. Let's say I've got the square root of 3 cis pi over 4. Pi over 4 is an easy one to change to degrees, isn't it? 45? So square root of 3 times the cosine of 45, I get square root of 6 over 2.
1.22.
What do you have as a decimal?
1.22.
And square root of 3 times the same thing. Should be the same thing for both of them. Is it?
1.22.
Is everybody agreeable on those? Now where are we at? Product?
Yep, one product.
Now what's the rule for product?
You
You multiply the r's
R and
add
add
the